thank you. Let's give it up for Daniel and Andres, everybody. Excellent. Well, hey, hi, I'm Tejas. Nice to meet you. I often introduce myself by saying I'm Tejas. That's pronounced like contagious. And like 9 out of 10 times, I'm not contagious. Today, I actually do have almost a common cold, so I may be contagious. Keep your distance, and whoever gets this microphone next, I'm sorry. But it's nothing serious. It's just a common cold, so I think we'll be fine. Over the course of my career, I've been able to work either as a consultant or as a teammate at some of the greatest tech companies in the world, and it's been an absolute joy. At some point, I hope my clicker doesn't work. Also, this is an AI talk, also a JavaScript like UI talk, and just before going on stage, Elian sitting over there, sent me a picture that said ChatGPT is having an incident right now, so none of this may work. Anyway, I've had the privilege of working at some of the, I love these companies. They're all great. We've worked together in some way, shape, or form, and it has really helped shape a lot of my career, and I bring some of that to you today, okay? The clicker really doesn't want to work, unfortunately, so I'll just stand here. I'm a developer experience engineer or developer relations engineer at DataStax. DataStax is a company that makes a database but also wants to be an AI company, and it's sort of my job to help them do that. But we're not here to talk about any of that today. We're here to talk about the idea that you are an AI engineer. That's sort of the title of the talk, and it may be a little bit pointed, but there's a lot to be said for AI engineering, and the whole purpose of this, let me start by telling you about the motivation. I want this to be accessible to you. If you feel imposter syndrome around AI, I want to remove that. I want you to be able to work in this space. Mainly because it's a new space and there's a lot of innovation, but also, if we're just being real for a minute, company valuations are the highest in the AI space. Salaries are the highest in the AI space. And I want you to live your best life, okay? I want this to be accessible to you. So with that, let's get started talking about this. And we'll have some demos given if we have enough time. So let's start by talking about AI engineering. What is an AI engineer? In coming to this conference, even before coming here, I asked a ton of people, what is an AI engineer, and do you think you could be one? Right? If I ask you, what is an AI engineer, and do you think you could be one? The answers I got were very surprising. People were going, oh, I couldn't be that. And I say, why? And they say, well, because I don't know anything about linear algebra. I didn't go to university and flip matrices. I'm not good at data science. I don't know how to train a machine learning model. And I'm here to tell you today that that has probably nothing to do with AI engineering. We believe this lie. We believe this, it's maybe not a lie, that's too strong of a word, but we have this misconception that machine learning and AI and data science are the same, or very close, but they're really not. Okay, and this is what I'm here to tell you today. I'm here to define this for you in a way that makes it accessible to you. And some will be like, oh, you're minimizing our work, whatever. Those are the same people who will tell you HTML is not a programming language, It's not technically, but it is because you can build programs with it. So this is where we are today. Okay, so let's talk about AI engineers. What is an AI engineer if it's not just a glorified machine learning engineer or a data scientist? To understand this, let's not take my word for it. You may debate whether I'm qualified or not to coin this term. Let's lean on people who are smarter and better than me in many ways. And by this, I'm talking about the great Sean Wang. Anyone know Sean Wang? That's like one person. Sean Wang, aka Swix, is a former finance person who turned into a web engineer and now is a leader in the AI space. He's the founder and CEO of a company called Small AI, and also runs a really powerful, influential podcast / newsletter in the AI space called Latent Space. Sean is like one of the global leaders in the AI space, and he, on the foundational article that he wrote titled The Rise of the AI Engineer, defines it this way. He defines AI engineering as this specific diagram here, which is you've got machine learning research, machine learning engineering before the API, and the AI engineer and the full stack engineer after the API. So this really separates machine learning and AI engineering from each other and gives you a nice basis for discussion, right? Further, underneath the diagram, what you see is a quote from the great Andrej Karpathy. Andrej Karpathy is the former director of AI at Tesla, so self-driving, he's the guy behind it, and also the director of engineering or director of AI at OpenAI, formerly, right? So like the leader in the space says this. What does he say? He says in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers because of this, because it's behind the API, okay? Or in front of the API, depending on how you see it. He says one can be quite successful in this role. What is that? Without ever training anything. So if I ask you again, do you think you could be an AI engineer? You don't need a machine learning research background. You don't need data science as a background. The application of AI to solve problems is what makes an AI engineer, according to all of this data. Okay, so what is engineering? Engineering is applying technology to solve problems. That is literally the definition. You apply technology to solve problems. What is AI engineering? You apply AI technology to solve problems. Right, that's the definition. So it could be, if this is the JavaScript track, if you're a JavaScript developer, it could be using AI. So you make a fetch request to ChatGPT and get some generated text and then use it to solve a problem. That could make you an AI engineer. Based on this is not me, this is Sean and Andrej, okay? So let me ask you again, I see people laughing over there. Let me ask you again, do you think you could maybe, okay, one final quote. This is something Sean says in the article. He says, this will likely be the highest demand engineering job of the decade. And we sort of see that, again, with company valuations and with the salaries. Some people are making like upwards of $600,000 a year just being an AI engineer in this very like undefined title. Okay, we've talked about AI engineering. Let's talk about AI. This term, unfortunately, is abused these days, right? Because it can mean many, many things. In fact, if you put AI somewhere in your slide deck, you'll probably raise a bigger funding round, unfortunately. AI is a term that now is just, you've seen the Google keynotes with Sundar going AI, 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 AI. What is it, 121 times he says AI. It's this word that is used so much and leads to so many good things / hype cycles that it is abused. Let's clarify this a little bit, because there's different types of AI. AI is not new. AI goes back to the year 1906, right? The beginning of the 20th century. A man named Andrei Markov created a statistical model called the Markov chain, which is the basis for natural language processing, which is the basis for what is called predictive AI. That's one of the types of AI here. What is predictive AI? If you have your phone, your smartphone, that was invented in 2007 with the iPhone, right? Debatably. If you have a smartphone and just above your keyboard you have these little suggestions for the next word, and you've played the game, right, where you just tap the suggestion and come up with some gibberish text, that is predictive AI. That was 2007. Right? Markov models from 1906, like this is not new. There's also rule-based AI, which is if you're playing Pac-Man, Pac-Man eats the little berries and the ghosts turn blue and avoid Pac-Man. That's AI, that's rule-based. It's literally artificial intelligence. It follows predetermined rules, or in the case of Markov chains or predictive models, it follows statistical models. Those are all AI. What we're talking about these days with the advent of ChatGPT and so forth, and the Transformers architecture, a paper published by Google, is generative AI. And so these algorithms are optimized to produce novel things given previous inputs. So you say like, hey, here's a combination of data, generate something for me, and what it generates is typically novel, right? This is closer to how also our brains work to some degree. So the hype is not around rule-based AI or predictive AI, which goes back centuries, or at least 1 century. It is generative AI, or sometimes called Gen AI. Clear so far? Great. Generative AI. So why is generative AI so hyped? Well, because it brings novelty. Imagine building a recommendation engine. You run Amazon.com, and you can show people, hey, here's products that you love. We know you love this because we have enough data on you, unfortunately, to sell you these things, right? It's generative. It leads to highly popular business outcomes. However, Gen AI has some problems. And remember, we defined AI engineering as solving problems with the application of technology using AI, right? Well, GenAI has some problems of its own. Some of you may have noticed this. For example, it hallucinates. It is often confidently wrong. Anyone experience it? Like Google just released the, it hurts me to even say this, Google released a feature called AI Overviews. I don't know if you've had the misfortune of using this, but gosh, like somebody asked Google, hey, how many cigarettes is it appropriate for a woman to smoke when she's pregnant? And Google's AI Overview, I'm not even making this up, said 1 to 2 cigarettes per day. Okay? Confidently wrong. Much like some speakers at conferences. I'm talking about myself. I don't mean this about anyone. Anyway, confidently wrong. And so that's one issue. It hallucinates. They see things that is not there. Number 2, every large language model that powers an AI application has a finite context length. Even something like Google's Gemini, right, multimodal, has a 2 million token context length. For those who don't quite understand tokens, it's roughly equivalent to 1 token equals 1 English word, roughly. So, words have arbitrary lengths, and so it's not 1-to-1, but it's close enough. So 2 million words is sort of the top level of context, which, if you think about it, isn't that much, right? It's sort of like a long book. You can't have your entire lifespan in such a context window and have an assistant like Jarvis. You can't do that. It's a limitation. Number 3, knowledge cutoff. So GPT 3.5, for example, has a knowledge cutoff, I believe, in still 2023. GPT 4.0, of course, is May 2024, but there's always like a date past which the AI models don't know stuff, or the large language models don't know stuff. So these are the big problems with GenAI today. I'm here to show you how to solve those and make it more accessible to you. Okay, we've got some demos. I don't know how much time I have, so we may be over, we may be under. There's an emerging technique that solves all of these problems and unlocks GenAI for real-time use cases. So an example, right? Imagine your target, and it's raining outside, and you want to, the timer's working, Daniel, it's okay. It's working, it's good. So imagine your target, it's raining outside, and people are going to target.com for some reason. You want to show them umbrellas based on the current weather, business. How can you do that? How can you give real-time information to a large language model that has a knowledge cutoff in 2023? There's a technique called RAG. Anyone heard of RAG? Okay, like 4. That's cool, that's why we're here. RAG stands for Retrieval Augmented Generation. So the G in GenAI is generation, it generates text. You retrieve data, so R, you retrieve data, you augment, you change the generated output. RAG, Retrieval Augmented Generation. In basic terms, you just get data from somewhere that's current, like get me the weather right now, give that as context to something like GPT-3 or ChatGPT. Hey, ChatGPT, the weather right now is it's raining. Okay, should they buy an umbrella? That's basically it. You just get data and you use it to augment generated output. RAG. RAG has some components. You obviously need data. You need like the weather right now. You need an embeddings model. Okay, what is an embeddings model? Embeddings models, they take text, so natural language like English, and each word is given a numerical representation in high-dimensional space. What is dimensional space? The human mind can comprehend like 3 dimensions, 4 if you account for time, right? So we have an x-axis, we have a y-axis. This is 2-dimension. Maps are 2-dimensional coordinate systems are 2-dimensional vectors, so x-axis, y-axis. Depth is the z-axis, so we have 3 dimensions. Whoa. High-dimensional space goes up to like 1,500 dimensions. What does that even, I can't show you that, but embeddings models take words and put them like in a 1,000 plus dimensional space, such that words like food and hot dog and cake land in the same location. And words like JavaScript and Python land in another location. So it's just assigning spatial meaning to words. That's what an embeddings model does. And finally, you need a vector store. And a vector store can do similarity searches based on these numbers. So if you search for food, a vector store will find you records about adjacent topics like hot dogs. If you search for code, it will find you, Visual Studio Code or Python. So it's just proximity search. These 3 components make up RAG. I'd like to show you a quick demo of this today. Using a product, so where I work, DataStax, we make a database, we make a vector database, so that for RAG. But we also make we recently acquired a company called Langflow. It's like LangChain, but it's a visual builder. And I don't want you to use it per se, but I want to show you the flow of how this stuff works, okay? And I think Langflow is a really great tool to do that. So let me come over here to my laptop, and I will run langflow. So we'll just langflow run. And so while that's running, let me come over to my Astra database. And I've got a database here called JNation. That's langflow. So I've got a database here called JNation. I'm going to create a collection, and a collection is just a table. I'll call it stuff. I don't really know. And I'll say I want it to have 1536 dimensions. And again, we talked about dimensions. And a similarity metric is like, how do you do the search? So I created this collection called stuff. Let me show you langflow. And what I'm going to do is I'm going to make a new project called a vector store RAG app. That's literally what we just talked about. And I want to show you the flow of data, because this is how RAG works. And I think it's really cool that they visualize it. So you start with a chat input, right? And an embeddings model. We just talked about an embeddings model. And you connect them to some type of vector database search. In this case, we're using Astra. That's my company's product. But you can use whatever you want. And you give it a token. So we'll say the Astra DB API key. And these are just environment variables. The collection name we just made is called stuff. And the input value, you see this line here, it sort of comes from the chat input. Okay? And the embedding model comes from here. So then we break the user input into some chunks, just so the text has some overlap with itself. And we generate a prompt. You may have heard of prompt engineering. This is the prompt. It says, given the context above, this comes from the vector search, answer the question as best as possible. And this is the user input. So we get this prompt. We pass it to a large language, we pass it to a large language model, in this case GPT 3.5 Turbo, with an OpenAI API key. And the chat output, that's really it. And what I'll do is I'll come here and maybe make it like stream the output, because I like the snappy UX. Okay, so now if I play this, right, it should give me a little chat UI. So I go to the playground, and it does that. But I can be like, so let's illustrate a problem, because Nike, anyone familiar with Nike? Anyone wearing Nike today? No? Nike, cool, man. Nike just released, literally, like recently, a Python framework for data pipelines. Nobody knows about this. It's brand new. ChatGPT for sure doesn't know about this. So it's called this. It's called Cohesio. And it's cool. It's a Python framework for data pipelines, right? So I will be like, tell me about the Python framework Cohesio. I believe the spelling is right. That's true. And of course, it's like, dude, my knowledge cutoff this doesn't exist. Or at least it should say that. Yeah, there's no known Python framework called Cohesio. But let's fix this with RAG. And this is exactly solving the problem with RAG. So if I come here, there's also an ingestion pipeline here. Check this out. So I can either from a file or some source, break it into chunks, use an embeddings model to insert the data into my Astra DB. So I'll use the API key, the same endpoint, collection name is stuff, and instead of a file, I'll just read from the internet. So I'll go here and add data as a URL, and I'll just paste this GitHub repo. Boom. And of course, you draw a line. This is very important. That's it. So now I'll choose the right embeddings model, and I'll insert this GitHub page into my database. And it's just going to like read the GitHub page. As you can see, it's inserting some records into my database. And you can do this as code. I just want to show you the diagram because I think we can reason about it nicely. And if I go look in my database, reload the page, we should maybe add some like WebSockets or something. Let's reload the page. And we have some, come on, we have some records, right? So we have, this is just a bunch of stuff from the GitHub page. Okay, what does that look like in practice? Well, if we come here, go back to our read pipeline, to the chat playground, and I'll just send exactly the same prompt. Tell me about the Python framework Cohesio. Let's see now RAG in action, because it's going to search that database for similarity, and Cohesio is a Python framework. Suddenly it just knows stuff. And it's still GenAI, but with more extended knowledge through a RAG pipeline. Is that clear? This is how you solve the problem of hallucinations, finite context, and knowledge cutoff. And you can look here on the left. This is all the stuff we actually got from the database after that ingestion pipeline. So this is something that, where I work, we're committed to making this very easy and accessible for people, because it can and does help you build more powerful things using GenAI. Okay, that's RAG, or Retrieval Augmented Generation, in a nutshell. Let's go back to the presentation. And while that's cool, while Gen AI can solve some problems, I'd like to take a few minutes and talk to you about going beyond just text. Okay? I'm talking to you about not just Gen AI, but Gen UI. Okay? Because, like, you remember we talked about the problems with Gen AI, right? We talked about these three. Turns out there's a fourth one if you consider like pleasant user experience on the web. The fourth one is that LLMs, they produce mostly text. And sure, ChatGPT can generate images. With Sora, you can generate videos. But ultimately, it's mostly text. And that kind of sucks, if you ask me. What if we could, we're web developers. This is the JavaScript track. This is the UI track, right? I want to make like nice UI instead of just text. How can we do this? We can do this with Gen UI. And I'd like to show you a little demo. What we're going to be using is the Vercel AI SDK. I used to work at Vercel. I don't do this anymore, but it's actually really great engineering, I must say. And as a former employee, like I can't. I should maybe have bad things to say, but it's actually really good. It's very surprising. But anyway, cut that out of the recording. I don't want to say it's surprising. So anyway, let me show you. So we have a project called Gen UI and NPX Next Dev. It's a Next.js app. And I know how you Astro people feel about this, but let's just roll with it for now. So this is a chat bot. And what I have is a little UI that says, ask me anything. Okay, so show me movies about future with AI. And I'm going to ask, and it just fails. You know why? Because nothing's implemented. So let's look at the code and build this together in like 20 minutes. Okay, so what do we have here? We have a layout. Anyone use Next.js here? This should be familiar to you if you use Next.js. We have a layout. We wrap our layout in AI. Okay, what is AI? AI is a call to create AI, where we have actions. This action, continue conversation, does nothing. And we have AI state, UI state, okay? What else do we have? We have a page, and we have messages, as you can see. Messages, let's reload this. Messages is this whole area up here, and the chat form is the chat form. And if you want to look at the code, messages just maps over conversations and shows you messages. And the chat form is exactly what you think. It's just a form that when you submit the form, we set the conversation to what the user input. We call continue conversation to get some output from the large language model. And then we set the conversation, which is just a big array of messages, to the new message from the LLM. So we're just like adding messages to an array. That's what we're doing, okay? So this clearly doesn't work, and it doesn't work because our action is undefined, okay? So we'll fill this in together and understand what's happening. So this is an async function. As you can see from the chat form, we call it with the input from the user. So let's just fill it in here. It's an async function that returns the, sure. Instead of, let's actually import nano ID to give it a unique ID. Instead of AI, it returns a message from the assistant, and its display value is sort of undefined here. So we need to define it. So we'll get some UI. So we'll say result is, and we get a function called stream UI. Okay? And stream UI gets some stuff. Most importantly, it needs a model. So we'll use OpenAI and hope that it's not having an incident that affects us. So we'll import OpenAI from AI SDK/OpenAI. And we'll use GPT 3.5 Turbo. Then you need some more stuff. You need a list of messages. We can get the history by calling a function called getMutableUIState, like this. And so the history now of messages is whatever's in here in history.get. And of course, we get the user input. So we'll do this. And instead of display, it's content. So this is just the input from the user, you know? And that's it. And so now, if we get the result, we can do result.value. Okay? Very simple. What are you complaining about? String. Okay, cool. This should be more than enough to just get a chat response. Let's take a look. So we come back here. Show me movies about the future of AI. Okay, cool. It kind of works. We're getting text, but it kind of sucks because it's a list, but it's not like, there's no margin between the list items. So let's fix it. So we're getting back here text, right? So what we can do is we can format the text a little bit. We can say for text, We get some stuff. We get, are you done? And we get the content. And what we can do here is return. Actually, if we're done, done, then we call history.done with history.get and the assistance message. And finally, we return content, which is just a string. But we can also do something cool, like we can wrap this whole thing in Markdown. Because guess what? We can return React components here. And so let's import Markdown from React Markdown. And we can even do a custom renderer. So we can say components, well, for P elements, you get children, and we can space them out a little bit. So we can say P class, we can use Tailwind CSS, why not, and do children. Look at that. And just like that, we have a little bit richer text. So now if we ask, we have at least some space between them. Wow, right? But why stop here with generative UI when we can return React components? You understand? So instead of this, what if we can add some tools? And I'll finish with this, tools. And we define a tool called Get Movies. And we search our Astra database with similarity search. We search all of IMDb from my vector store and get similar movies. So we'll do Get Movies. And the tool gets a description, thank you Copilot, right, by a prompt. And we get parameters. This needs to be a Zod schema. If anyone uses Zod, it's just a way to type objects. So we'll import Z from Zod. And parameters is a Zod object with a prompt that's a string. And we can even describe it if we want. Come on, Copilot, do your thing. Whoa, perfect. And finally, we need a function called generate. It's an async function that is type safe. That gets, if I have a typo here, you see that? It's supposed to be product. It just gets it from the schema, okay? And so now what we can do is get data from my database. So const db, or actually let's do client. And we'll do the same thing, data API client from Astra. We just talked about that. Process.env ds API key. And that's defined. Const db is client.db. And we just get our ds, that's DataStax API endpoint. It's defined. And then we'll just say data is we'll await db.collection. We have a collection called IMDb OpenAI. And we'll find movies that are similar to the prompt. So we'll be like, find where, vectorize. So we convert the prompt into a vector. And we turn it into an array. Okay? We get the data. Now what we can do with this data from our vector database, we're doing RAG here, we can return a React component. Let's do it. So we'll return div. Actually, let's do a UL. Let's be semantic about this. And look at that. Fantastic. Data.map. Movie is any. Fair. We'll do key is movie.id. And here we can go absolutely nuts. We can do whatever we want. We can, for example, let's make it a flex box. Class name flex, items center. This is Tailwind, by the way, and you can see why it's actually giving me a Tailwind. I can write this style so fast. Okay, and here I could do look at this. I can do an IMG. I can even do something like width is 100, height is 150. We can maybe do a limit of 8 so we don't get too many records. And we can show the movie title here. So maybe an H2. Movie.series title. Of course, these are fields on my database, so I could do poster, link, and just kind of do this, okay? This can work, but let's make it even better. Let's do like class name rounded, give it a shadow, you know. Let's even go here and be like, look, let's transition everything. So animations, and when you hover, then we like raise it, you know, just like go absolutely bananas. Okay. This seems to be okay. I'm not seeing any issues. So that's kind of what we did. We got a search result from a vector database and rendered a bunch of images. Let's see if that actually works. So I'll run the same prompt and show me movies about the future of AI. And please don't disappoint. Oof, look at that. And it like, ooh, you see that? Incredible. Wow. We went from this to this. Unbelievable. Now we could do even better because like this doesn't do anything. It's just sort of links. Let's fix it by making them anchors. So we'll just wrap this in href is imdb dot. Oh, wow, Copilot, you are so cool. Instead of this, we'll do like find q equals movie dot series title, and we'll close this here. And let's also do a target. At this point I'm just hacking because I have time. Okay, this looks actually pretty nice. Save. So now it's a link. Let's try this again. But what you'll notice is this. It's stuck for a while, right? Do the links work? Fantastic. Come on, IMDb. Oof, brilliant. Okay, That's great. This is a great movie, by the way. Okay, so the final thing is we want pleasant user experience, right? And this kind of sucks. Like, look at this. Show me movies about. If I click ask, there's what is that? Yuck. I don't like that. So using generator syntax, we could do even better. So instead of this async arrow function, we could do a generator function. Ooh, okay. And now because it's a generator, we can yield whenever we want. So we could be like here, yield. Starting, and this can also be a React component, so I see the dots in your head connect. We can then be like searching Astra vector store, right? And then finally it will return. So we give this beautiful feedback to a user, and that's why we're here. It's the web track. We care about user experience, okay? This can also be, as I mentioned, a React component. Okay, let's maybe not have the doom and gloom future of AI. Let's show me movies about happy comic book things. I don't know. Batman. I don't know. This is probably going to go wrong, but let's see. And so now you have searching. Oof, you have this beautiful feedback, and indeed it is about Batman. Holy smokes. So this, let's take a moment and appreciate how it started and how it's going. Okay, we started with this. Yuck. We then, okay, cool, we have some spacing, but why? Why text? Why not rich web UI with animations, with components, with links, etc.? I want to wrap up by saying, look, this is an example of a chatbot, but honestly, I think chatbots suck. If you're building a chatbot with GenAI or even GenUI, you've missed something. Because I use this for an illustrative purpose to show you, like, we started here, we're going to go here. But imagine you have an e-commerce store. You want to use GenAI, GenUI, to get similarity of products that people have bought, and you want to build a recommendation engine. Maybe it's not an e-commerce store. Maybe it's a Visual Studio Code extension store. Here's some extensions you may like that are open source, because this is not for profit, right? Instead of a chatbot, what if you had a section of your UI, like a row of icons, and these were generated using GenUI? You can do that. Let's wrap up. I do want to also basically give you some more context, because what I just showed is taken to another level by the great work of a friend of mine named Evan Bacon. Evan works over at the Expo team. Expo and React. Expo is like a framework for React Native. And what I just showed you, Evan has built to do on all platforms at the same time with one code base. So Android, iOS, desktop, web. That GenUI piece comes to all platforms. And with iOS, it's like native iOS components. It's not even like web component. It's absolutely nuts. So if you want to watch his talk, I highly recommend it. Let's talk about the future. That's where we are with AI. We started with me asking you, are you an AI engineer? And you're going like, oh, I don't know, machine learning. I'm not a data scientist. Well, you don't need to be. AI engineering is a whole new field with things like RAG, vector stores, GenUI. How do we process stream responses to give users value? This is AI engineering. This is the web track. This is the JavaScript track. Let me ask you again, could you be an AI engineer? I hope I've made this more accessible to you today, okay? Let's talk a little bit about the future. That's where we are today. Where are we going? There's a lot of talk about two things in particular I want to focus on. One is agents, AI agent workflows. OpenAI calls us the assistants, as Zach told me yesterday. But ChatGPT, large language models are cool. But at the current point in time, they're really great at like generating you an email that you can copy and paste to your team. They cannot create an email and then send it for you on your behalf. Okay? This is where we're going, though. like a lot of us, I'm working on exactly this. So I run a podcast. Each episode is very long. It's like 2 hours. And we ship episodes twice a week, every Monday, every Thursday. And we can do this because my podcast is run by a team of AI agents. They literally like do the work. Somebody schedules something with cal.com, and immediately an agent is like, who are you? Researches them, creates a discussion outline, sends it to both of us. We read it, we go, right? AI agents that can execute tasks on behalf of users is where we're going. And there's plenty of ways to do that. Unfortunately, there's 5 minutes left. I'd love to give you a whole lecture on that, maybe sometime. That's topic number 1 for the future. Topic number 2 for the future is small specialized language models. So GPT-4 has many, many billion parameters. And by the way, a parameter, when you hear about large language models, is think about it as a little dial that you can turn. If you've seen like a mixing board for sound engineers, you know, there's all these like knobs and they turn like bass and treble and volume and stuff. Large language models have parameters that are just like fine-tuning like billions of knobs to give you the right output, okay? So GPT-4, billions of parameters. Mistral, an open source company that makes large language models based in France, they have a model called Mistral 7B. That means it has 7 billion parameters, which is actually much smaller than the bigger models. This is cheaper to run, runs on my Apple Silicon, on my GPU. I can run it locally, and I can fine-tune it, meaning I can train it for my specialized use cases. This is the future of AI. Because the big models require way too much compute, way too much resources to not just train, but also run. And so as we move towards a future, we're going to look at smaller, fine-tuned, specialized language models that are democratized, meaning we can all run locally on our machines. And so if you're interested in further study, I'd recommend those two. Let's summarize all that we talked about today, as ChatGPT would. We looked at the question, are you an AI engineer? We looked at a diagram from Swix that Andrej Karpathy, head of AI at various companies, has corroborated. There's a line between machine learning, the line is the API, and then there's AI engineering outside of the black box API. This is like fetch from OpenAI. We established that. We established problems with AI, RAG as a solution for hallucinations, for finite context length, and for knowledge cutoff dates. Finally, we looked at a demo with Langflow on how RAG even works, and we literally taught GPT 3.5 Turbo something new. This whole Nike thing, it didn't know about it. It literally said there's no Python framework. Later, we taught it, and there was. So this is how you can extend it for your workflows. And finally, we looked at generative UI. That's all I have for you today. I hope this has been useful. I hope this is accessible to you. Thank you so much for having me.